Hi, everyone. Thank you for joining us. We have Chris Cooper here today conducting a training on certified crimp steam safety and savings. If you have any questions during the webinar, please use the question feature and we'll go over all of your questions and comments during the wrap-up section at the end. So without further ado, I'll pass this over to Chris.
Well, thanks, Courtney, and good morning, everybody. I hope everybody's having a good day wherever you are. I am coming to you from beautiful Franktown, Colorado, and it's a nice day here. So let's get started with certified crimp steam, safety, and savings. So this bad boy was, this big boy was in the yard, so I figured I'd take a picture of him and use this slide to remind you that there's a question box on the right-hand side in that control panel that you have. So remember to ask your questions in the dialog box to the right. You can ask them anytime during the presentation and we'll address the questions at the end of the presentation. Steam. So steam is created by converting water from a liquid state to a gaseous state by adding heat. And the operative word there is adding heat, because the steam systems we're going to talk about are closed systems, like an old steam locomotive. That's a closed system, and you keep adding heat to it to create your locomotive force or your pressure. This is important. Steam service is perhaps the most difficult application for rubber hose. Heat is the Dr. Evil of most synthetic rubber compounds. Sorry for that poor impersonation, but you'll get it in a few slides. Dr. Evil there is meant to be the arch enemy. So heat is the arch enemy of most synthetic rubber compounds. The hose expands and contracts with each heat cycle, and steam hose is rated for a maximum of 250 psi at 406 degrees Fahrenheit. So steam in industry is used to lubricate and enhance flow, clean tanks and vessels, keep process equipment running smoothly and efficiently. So in our industry, the things that we're seeing out there, steam uses are petrochemical refining, that's chemical plants, as well as oil refining, food processing plants. Now there's two types of steam in food processing plants. One is called a culinary or sanitary steam, and that would be for food contact, and we're not addressing that here today. We're addressing plant steam, which is essentially for heat. Oil and gas exploration, paper and wood products, textile mills, power plants, and more. You'll see steam basically in almost any kind of plant operation that you're in. Look for it. You can tell that they have it by the hissing sound and the clouds of condensation. So petrochemicals, this is a refinery in California. We did a hose survey, and you can see a little steam cloud under the A in petrochemicals. And obviously in a refinery, steam is prevalent. It is everywhere. When you walk into a refinery, you're really talking steam hose first if you're selling hose. Oil exploration. This is an oil rig outside of Williston, North Dakota, and steam is used to keep things running and product moving through pipes and equipment running efficiently. And you can see the grass is green, so this is not obviously winter, but in winter it's used for even more so for heat. And so this is Dead Horse, Alaska. This is the beginning of the Alaska pipeline on the Arctic Ocean. This is two 6 million pound walking rigs that I took a picture of a number of years ago that had just got off the barges, and those things are getting ready to roll out onto the tundra to drill, because that's the only time of year they can drill in the winter. Now this is September. It was probably 20 degrees and very windy and snowing. And the steam generation on these units is definitely for heat at -65. And that -65 is probably a normal temperature. Wind chill might be -100, -120. It's crazy. Steam tracing for process flow. This is a very cool picture. You can see the steam hose taped to the valves and piping in this process plant to keep things warm, flowing, and running smoothly. And of course, cleaning. So this picture is kind of a stock picture I found. It looks like Keith Richards with a steam wand. So we'll get to why the steam wand is important down the road in this presentation, but cleaning is a very important part of it. Steam really can clean just about anything, steam under pressure, so this is an important notion within the industry. Poll question number 1. Courtney, if you could pop that poll question up, that'd be great. And this is kind of I'm trying to keep it light here, so this is kind of a goofy poll. All right. So we've got, people are thinking about it. Come on, people. We're at 50% voted. We'll give it a minute and get more people voting. There we go. We're at 64%, 67% voted. Wow, this is all over the lot, but generally you are at 70% voted. We're going to close the poll, and the results are up on the screen. We got 51% ZZ Top, 33% Bruce Springsteen, 12% Bruno Mars, and 4% Justin Bieber. And the answer is ZZ Top. So we'll jump right back into it, and you'll see why I asked that question in a moment. Why is steam so dangerous? Well, it's freaking hot. There you go. That's the reason for the poor impersonation of Dr. Evil. It's freaking hot. And it's under pressure. Hence the poll question. This is crazy, but I have a little fun with it. And it's dangerous, just like this 500 pounds of cats that we caught on a trail camera outside the family cabin in Steamboat Lake, Colorado. So you'd hate to walk out the door midnight or something and see these three. Yeah, they're probably 180 pounds, 170, 180 pound cats. They are dangerous. And this is just to remind you that steam is dangerous. That's what we're talking about. Steam follows a precisely defined, documented set of physical laws. What does that mean? So let's take a look at a steam pressure and temperature chart. This chart is actually two halves, left and right. And you'll notice that the yellow boxes at the top encapsulate the two columns we're really looking at on each half. The left half, the yellow box, if you look inside, you've got the gauge pressure in PSI on the left-hand column and the Fahrenheit temperature in the right-hand column. And that left-hand half of the chart runs from 0 to 65 PSI and the associated temperature next to it. And on the right-hand half of the chart, 70 PSI to 300 PSI with the temperature to the right of it. Now, back in school, we learned that steam starts at water boils at 212 degrees. At 212 degrees, the actual pressure is 0 PSI. So again, when I said it in the beginning, the locomotive, the steam engine, it's a closed system. So as you keep adding heat, you raise the pressure and you raise the temperature. So as I also said in the beginning, a full steam hose is rated to 250 PSI, and that is at 406 degrees. So let's make sure everyone understands that at 250 PSI, steam is at 406 degrees. It's a physical law. It cannot be at 200 degrees. It can't be at 220 degrees. It's at, or 400 or 420 degrees. It's at 406 degrees. It's important to understand. Why is it important? Well, if your end user, and I had this happen to me, that's why I brought it up. I was in a sulfur reclamation plant in Billings, Montana, and they were using, of all things, Chicago fittings banded onto a steam hose for steam jacketed pumps that were in the ground. And as we all know, putting a Chicago fitting on a steam hose is crazy. It's complete no-no. The guy said, yeah, but it should be okay. I have the red gaskets in it, the high temp gaskets. Oh, okay, good. And we're not running at full steam. We're only running at 150 PSI. So let's look at 150 PSI. 150 PSI, 366 degrees with a universal crow's foot, Chicago, whatever you want to call it, fitting on the end of it. I didn't want to be anywhere near it. So when your end user says, I'm not running at full steam, it shouldn't be a problem, this chart is very helpful to say, you're still crazy. It's very dangerous. And so let's take a look at 60 PSI, 307 degrees, 100 PSI, 338 degrees. Look, you wouldn't stick your hand in 0 PSI steam, which is 212 degrees, let alone any of these other temperatures and pressures. So it is extremely dangerous. Let's take a look at what's on the end of a steam hose, the steam ground joint basics. The male stem, now these pictures of the stems that are going to go in the hose for steam would have a staked on ferrule, which we'll see in a few slides. These do not, because these are 3D renderings and we did not have them ready yet for actual steam fittings. So when we talk male stem, that would have a machined ferrule staked onto the outside of it. That male stem for a steam hose would be called an IMS3, and the suffix of a V denotes the Continental steam hose. V was for Vayance, which they owned Goodyear when it was Goodyear hose, and now it's Continental, and the V hasn't changed. So IMS3V is a 3/4 inch male stem for a Continental steam hose. And underneath it, you'll see an IMS3V SW, and that is the swivel version. It is an installation swivel. So that is available in 3/4 and 1 inch. The next is a female stem. So you've got the female stem and a nut on that particular part number, which is a GJS for ground joint stem, -3V, so that would also be for 3/4 inch Continental hose. The female spud, that's a GFS-3 for ground joint female spud, and then a male spud for GMS-3 for ground joint male spud. And then on the bottom row, the wing nut, a GN3, the low profile nut, an RGN3, and we'll go into the low profile versus wing nut a few slides from now. And then on the bottom right is a complete set, the GJF-3V, GJF being ground joint female set. It comes with a spud, a female spud. Now, let's talk bolt clamps for a moment. You're going to see bolt clamps out in the plant all over the place. They are very prevalent, and this is a 4-bolt clamshell style clamp, and I put this up to show you that the clamshell style clamp does not fully encapsulate the hose. Now, this hose is probably not a steam hose, but it doesn't matter because I wanted to give you the idea that you can see the two halves do not completely encapsulate the hose. That forms a pinch point, which is ultimately a leak path. And here you have a picture of a wonderful, this is a steam hose, and this is in a refinery in California when we did a hose survey, took this picture. And in the upper right, you need to understand that thermocycling is what I talked about at the beginning with the steam expanding and contracting the hose during each heat cycle. That's thermocycling. Each heat cycle expands and contracts the hose compounds, creating issues keeping the fitting secure with bolt clamps. It loosens the nuts. And then on the bottom of the screen, you'll see you're supposed to re-torque the bolt clamp prior to every use. Now, for those of us who have been out in plants and seen the steam hoses lying all over the ground, you don't see a torque wrench anywhere nearby. And by the way, look at the picture of the rusted Hulk in the center of the photo. Tighten that with a torque wrench. It's not going to happen. And that was in the refinery. That's not in the junk pile. That's sitting there ready to be put back into service. So this is an accident waiting to happen. If you need to use bolt clamps, the Campbell IC bolt clamp is the solution. Why? The interlocking 360-degree design wraps completely around the hose for superior retention and eliminates leak paths. So you see the yoke on top, it says casting, and the liner on the bottom. Those two fully encapsulate the hose. The U-bolts go around it, fit into the wave on the liner, and all the nuts are on one side of the hose. Very easy for your guys in the shop to torque the nuts, and it is leak-free. But let's be real about it. It still has nuts. It's still a bolt clamp. So as with all bolt clamps, you must retorque the clamp prior to every use. Good luck with that, because it's not happening. Not in the real world. It's available 1, 2, or 3 U-bolt clamps depending on the size. Steam would be generally 1 U-bolt clamp. It's available 1/2 inch through 6 inch size. Now this will give you a good idea of what we're talking about with the leak path created by the clamshell clamp. On the left-hand side, the clamshell clamp has been removed, and you can see the pinch point between the two halves. That's your leak path. On the right-hand side is the Campbell IC clamp. After it's been removed, you can see the hose is fully compressed 360 degrees around that stem, forcing the tube of the hose into all the serrations on the stem for tremendous holding power and leak-free service. All right, so this is just a little break here. This picture is taken in Estes Park, Colorado. Now, I don't know if anybody on this webinar has ever been to Rocky Mountain National Park or Estes Park, but in September every year, it's the elk bugling season. And the elk come out of Rocky Mountain National Park and essentially take over Estes Park, Colorado. I think if you waited long enough, you would see an elk go through the drive-thru at Wendy's. They are on the street, they're on the sidewalk, they're right outside your front door. You have to be careful. These things, they can be up to 800 pounds, and they've got quite a rack of pointy antlers on their head. So, yeah, it's very cool. If anybody is interested in seeing elk, it's not. I hope I see one. I hope I see 1,000 of them. All right, back to the subject at hand. Crimp steam. So, Crimp steam, the Crimp VITON sealed ground joint couplings for steam hose. Improve plant safety, save money with the Campbell Crimp steam system. Very important that you understand the focus of this is safety and saving money. Problems. We just looked at one of them, leaky bolt clamps. Generally, if you see bolt clamps, they're leaking because of the pinch point over time. Brand new, they might not leak, but they might leak even brand new. And leaky coupling interface. Let's take one at a time and look at this. The coupling interface leaks. The traditional bullnose steam stem and polymer seat spud connection is a poor interface between the mating parts. You can see in the inset picture on the left that the polymer seat is that black area underneath the bullnose on the right and left side. or the arrow points to the polymer seat, that polymer seat is actually impacted by the steam. So the steam, just like the hose itself, it thermocycles that polymer seat and creates a permanent hard set in it. This starts to leak, and hence the wing nut. Guys walk around the plant with a hammer, anything they have in their hanging on their belt, a pipe wrench, and they just whack the living crap out of the wing nut to try and seal it. And a lot of times it'll seal. Every once in a while, the wing nut gives way, cracks, the steam hose blows off. And as we went through earlier, when the steam hose blows off and there's steam coming out, it is dangerous, because if it's at fully charged, it's 250 psi, 406 degrees. Somebody is going to get burned, hurt, or killed. And you can see in the bottom right inset picture, the heat and compression forms a permanent seat in that polymer spud. That one came off. Hadn't been on there that terribly long, or it would have been more rusted. But you can see that seat. And if it gets damaged or anything, it's just a soft material, and then it gets hard as heck, and it'll leak. The solution, the VITON seal ground joint. In the inset picture on the left, you can see the precision machined metal-to-metal seat. What does that mean? Well, the connection actually seals metal to metal within the interface. And then you'll notice the arrow from the VITON O-ring secondary seal pointing to that little dot next to the metal face interface. That is the VITON O-ring. And you'll see it also in the right-hand inset on the female stem. That's a standard size O-ring. It's replaceable. It's 75% encapsulated in a machined groove on the female stem, and it is leak-free, hand tight. So no more beating the crap out of a wing nut to try and seal it. It's leak-free, hand tight. Now, with that being said, you'll see that on the bottom, I have the parts listed: wing nut, low profile nut. So there's two nuts available. We sell the bulk of the steam hose that we sell with the wing nut. And why is that? Well, people still like to beat the crap out of stuff. They're used to it. They've been working in a refinery or a plant where there's steam for the last 20 or 30 years. They've been hitting wing nuts forever. So they walk around, they want to see a wing nut, they want to hit it. I don't know that they're hitting it if it doesn't leak, but we sell a lot of wing nuts. The low profile nut in the inset picture on the right, you just hand tighten that and it's leak free. Coupling interfaces. Now this is something you need to understand, because if you're going to sell a steam hose with the Campbell crimp system on it, somebody's going to ask you, but I have the old style spuds on all these drops within the plant. Well, the best interface, no question, is the one on the left, the Campbell stem and spud. That is the metal to metal seat with the VITON O-ring backup. The worst one is the one they might have in a lot of plants, the competition stem and spud. And again, it's got the polymer spud with the bull nose fitting. It's a poor connection. It's going to leak. And then on the right-hand side, you'll see it's the Campbell stem with the competition spud. And it does seal. So you could sell the hose. You will want to talk to your plant operators to say you would, over time, as a running change, you should change the spuds, and you'll have leak-free, hand tight. The seal interchange on the right-hand side is good, but it's not as good as the Campbell stem and spud. Remember leaky bolt clamps? We just went through it not that many slides ago. So this picture on the upper left is another pinch area. It's a different hose. That's actually a steam hose. So was the other one with the pinch area. But you can see how the leak path is formed by the clamshell clamp not wrapping around the entire hose. And of course, the inset picture on the bottom right is a leaky clamp. You got to retort the nuts to try and seal it. You're going to hit the wing nut to try and seal the interface. I mean, it's inefficient as heck, and it's leaking steam everywhere. The ultimate solution to that is the Campbell Crimped steam system, which you can see the inset picture on the left has the staked-on ferrule, and that is what bites to the wire to achieve full electrical continuity. And you can see in the inset down the bottom right, that is a picture of the actual ferrule with the machined ribs that you can notice. Those are what bite to the wire to achieve full electrical continuity. Now, why is that important? You can see Keith Richards again with the steam wand in his hand, the little inset picture. Well, if it's not a fully electrical continuity on the hose, then the steam particulate actually generates static charge. The static charge collects in the wire pack of the hose. If it's not grounded, it doesn't dissipate. So it gathers and gathers and gathers in the wire pack until Keith Richards goes to put the steam wand back on the rack. When it touches the metal, it discharges and hits Keith Richards pretty heavily. It can be quite a charge from steam. So it's very important that the hose is fully grounded with the bite to the wire electrical continuity. You don't have to do anything. You know, the old style with the bolt clamp, you had to stick a staple in and hope, and over time the staple would rust and wouldn't be electrically continuous. So this takes that away without even thinking about it. And there are no nuts. There are no nuts to retorque. It's a permanent attachment. You do not have to retorque any nuts. And obviously, if you're pulling hose along the ground, there's no nuts to grab, to snag on anything. It's just a much better solution. Poll question number 2. Courtney, if you could pop that question up for me, that'd be great. Let's see. So this one is not as goofy. This is just to give me an idea of who understands the temperature derating chart that Campbell publishes. And for those that aren't familiar with it, we're going to get familiar with it once we have this poll to a point that we can see what the level of familiarity is. 62% voted. When we hit, say, 70 or 75%, we'll close it out, and that'll give us a good indication of where we are. Okay, so at 67% voted, it's 61% yes, 39% no. So 60-40. So let's take a look at steam hose attachment maximum working pressure ratings and how those are calculated. And this is where the temperature derating guide or chart comes into play. In the first chart on the top, and these are all taken from the handout Campbell Coupling Selection Guide. I will send this to you as a follow-up for being part of the webinar. You'll get a PDF of the Campbell Coupling Selection Guide, which includes both these charts. The top chart is just a snippet. I cropped the photo of it down to just the steam hose. And you can see here, whether it's a U-bolt clamp on a steam hose or a staked-on ferrule, which is the crimp steam, that the rating at 70 degrees Fahrenheit, that's important, is 1,250 PSI. It's actually 1,500 at the half inch on the U-bolt, but we're talking crimp steam now mainly. 1,250 PSI. So let's look on the bottom chart. Remember, that's at 70 degrees. The bottom chart is the temperature derating guide. You see the steam row, the top row of the chart. You come across to 400 degrees, and we're not gonna argue about it. 400 or 406 degrees, who's counting? It's dangerous. So you can use the 0.20 multiplier to get your final pressure rating. So if we look at that, we say, okay, we got 1,250 PSI at 70 degrees Fahrenheit times your temperature derating multiplier of 0.20. That's the derating multiplier, equals 250 PSI at 406 degrees Fahrenheit. And lo and behold, That is the max working pressure and temperature of the steam hose. Now remember, there's a difference between steam hose and other industrial hose. The ley line on other industrial hose might say 250 psi at 200 degrees. You really wouldn't want to test both the maximum pressure and temperature at once. Those things are listed on the hose as guidelines, but you really would not want to push both at the same time. Steam hose is different. Since steam has got the physical characteristics of elevated temperature and pressure at the same time, the steam hose must take both at the same time. So it's important to understand. Campbell Crimp steam savings by the numbers. This is critical. 2.6 pounds of steam loss. That's the estimated steam loss per minute per 1/8 inch leak. So that would be, your standard leaking coupling interface or bolt clamp. $12, and it's actually $12.29. So I rounded down on this. $12 the cost to produce 1,000 pounds of steam currently. $45 is the cost of that one leak on one end of a hose for one day. $315 is the cost of that one leak for 1 week. $1,323 is the cost of a leak for 1 month. And we put together these numbers as a 5-month average steam season. Depending on where you are, if you're in Edmonton, it's 5 months. North Dakota, 5 months. If you're in Houston, it's probably not 5 months, but for this calculation, we used 5 months. Saving or costing, depending on whether you've switched to crimp steam, $6,615 per leak, not per hose, per leak for 1 season. So there's your selling feature. So this is kind of an important screen here because this is the focus of the presentation. What makes the Campbell Crimp steam system certified? Well, let's start with the 1,000-hour rack test. It's steam rack tested by the hose manufacturer. After the Campbell engineers and the hose manufacturer engineers come up with the crimp spec to be tested for the attachment of the hose ends, the ground joint crimped ends. What is a 1,000-hour steam rack test? 23.5 hours at full steam and a half an hour off every day for 1,000 hours. After that, it's taken off the steam rack and put in the hydrostatic tester, and then it must meet the requirement of going to 2,500 psi with no leaks or failures at 70 degrees Fahrenheit. And that gets you your verified 10-to-1 safety factor. So there's no crimp spec that we publish for steam hose that has not gone through a 1,000-hour rec test by the hose manufacturer after Campbell engineers and hose manufacturer engineers have come up with the crimp spec. So the engineered crimp specs, and it's engineered not just by Campbell, but by the hose manufacturers and Campbell Fittings in conjunction with one another. So it is safe. Campbell certified steam hose. So your choices. Remember, this is certified. You can't just take an import steam hose and slap a Campbell crimp fitting on it and squeeze it and say, okay, that should be good. No, these are all certified and tested. So Continental FLEXSTEEL 250, various different part numbers, a 1/2 inch, 3/4, 1 inch, and 2 inch with 1.5 coming soon. Gates Steam King 205 MB and Steam Queen 232 MB with 3/4, 1 and 2 inch. Eaton Concord 250, which is number H9568 and 3/4 inch was just certified. And as well, we have the Goodall hose in 3/4, 1 and 2 inch. That is an Eric's proprietary hose that is also certified by Campbell and Goodall. Crimp specs are hose specific, and they come in the box with the fittings. Ask your salesperson for the specific hose part numbers to make sure that you are using the Campbell fitting on a hose that has been certified. It's very important. That way you're going to get, everybody can sleep at night. It's going to be safe. It's going to be leak-free. Crimp steam system is manufacturer tested for tens of thousands of hours. The rack test. Millions of hours in service. The steam fitting, the crimp steam fitting are not new from Campbell. They've been around for about 18 years. So we estimate we have saved industry, and I'm not going to read that number, but that's about $2 billion, and that's billion with a B, just by changing from the conventional old-style bolt clamps and bullnose polymer seat interface to the Campbell metal-to-metal seat and crimp steam leak-free hand-tight system. Oh, pay attention, class. This picture is taken. This is a very cool picture. It was a wonderful thing to see. But a fox had a den of pups. My next door neighbor's front porch or deck, they had their den underneath it, and for about 6 weeks, these little pups were out playing around. I mean, this was only about 30 feet from the driveway, and it's really something. So I thought it was just an opportunity to say, pay attention and ask your questions. In the box to the right, there's a drop down there. It says questions, and you can type them in, and we'll answer them in a few slides. Selling steam. So after all this, you now understand steam, and you understand the attributes of the Campbell steam system. How are you going to sell it? If it leaks, it's an opportunity. That is big. If you're in any plant, if you're anywhere, and you see steam hose, then you see it leaking, or you hear it leaking. That is an opportunity to get a hold of the plant operator, somebody who gives a crap, essentially, because if it leaks, it's an opportunity for you to talk to them about getting them into something that doesn't leak and is considerably much more safe. If clamps are required, remember we went through the IC U-bolt clamp, the Campbell IC U-bolt clamp. It's a far superior system to the clamshell clamp. So if you see the clamshell clamp, you should be talking about the IC clamp. It is leak-free as well. And remember, the interface coming out of the end of is still the Campbell ground joint system. So it's got the metal-to-metal seat, the VITON seal backup. So it is as well leak-free hand-tight. So the clamp won't leak and the interface won't leak. So if you need to sell clamps, the IC U-bolt clamp is far superior. So selling Campbell crimp steam. Here are your bullet points. It's certified. We went through why it's certified. CRIMPNOLOGY specifications. You get the crimp spec in the box. It is very similar to hydraulic hose. This is not the Campbell system for industrial hoses. Measure the hose wall 3 times, take an average, look up the crimp spec. With steam hose, it's verified by the hose manufacturer, and steam hose is a much tighter tolerance. So the hose is very, very consistent. So the crimp spec is always the same. So you get the Campbell fitting in the box, you get your hose, the appropriate hose, put it together, and you back it off just a little bit so that you allow for hose growth. You crimp it to the specification, and you're done. It's very simple from an installation standpoint. So that's the CRIMPNOLOGY specifications. The 1,000-hour rack test. I mean, come on, this thing is tested. It is not going to fail. It's been out there for 18 years. It's proven, leak-free. The 10-to-1 safety factor. My goodness, this is tested to 2,500 PSI hydrostatically after the hose is cooked for 1,000 hours. The metal-to-metal seat, the VITON seal backup, leak-free, hand-tight. My goodness, you're not losing any steam anymore. And the bites of the wire, full electrical continuity. There's no more static charge buildup in the hose. And the last slide, the crescendo, payback. When you're selling crimp steam, the payback to the end user, if he's got leaky steam, clamshell bolt clamps, and bullnose polymer seed interface, the payback to the end user for Campbell Crimped steam hose is extremely fast. And when I say that, I don't know what people are charging exactly for steam hoses, and it depends on the configuration and the length of the hose. But it's safe to say that the payback for a hose that replaces a leaking hose is somewhere between a week and a month. So we can go back to that other slide which says if it leaks, it's an opportunity, but that's really where we are. So let's take a look and see if there are any questions, comments, and I will be happy to answer them. Courtney, do we have any questions?
We do. We have a couple.
Okay.
First question. When would you use a ferrule with the wave bump versus the grounding style with the biting stakes?
The ferrule with the wave bump. I assume someone is talking about the heat wave, which is also a staked ferrule product, and that is used for air hose. So the heat wave product, which is similar to the steam product, the steam product has machined ribs on the inside of the ferrule. The heat wave has machined a wave on the inside, so it does not bite through the cover and bite to the wire. The heat wave actually has one rib that bites the wire to ground it. But otherwise, it's a wave because the air hose, the configuration of the air hose in terms of the manufacture of it does not allow us to bite through the wire. It just falls apart. The steam hose is designed to bite to the wire from the get-go, and that's how it's fully electrical conductive, and that's how you get to the 10-to-1 safety factor. So that's when you would use it. One's for air hose, one's for steam hose.
All right, I have a follow-up question to that.
Okay.
If it's a steam app, you should always use an electrically grounding ferrule connection. What about clamp style? Are those electrically grounding?
Well, the clamp style does not automatically electrically ground. You must use a staple or some other wire product to insert into the end of the hose into the wire pack and then down into the inside of the hose so it contacts the stem of the ground joint. And that's the way it's been done from day one. And generally it's a staple. And the staple rusts, and over time the electrical continuity goes away. So the bolt clamp, whether it's IC or any other bolt clamp, requires an extra step to ground it, and it's not 100% accurate. So the crimp steam grounds automatically. The bolt clamp does not. It takes an extra step.
All right. Another question. Wouldn't steam leaks in a plant become an instant safety issue and they are addressed quickly by a plant manager, or is it common for leaks to be ignored?
Well, you can imagine that in a plant where steam hose is prevalent, people are walking around whacking the wing nuts to try and stop the leaks. But if you've been in any of these large plants, the leaking steam is pretty much everywhere. And in talking to the end users or the operators of the plant, you get comments like, "Well, that's just what it does." And yes, it is a hazard. It can be a worse hazard in the winter because if it leaks, it condensates, it freezes over. So you have slip and fall hazard, you have puddling, not to mention the leak from the actual steam. So although people will try to stop them from leaking, generally speaking, it's leaking. So there's your answer. If you see it, and if there are steam hoses, you will see them leaking. And that's the opportunity to talk to somebody about the leak-free, hand-tight, the whole system.
All right, one last question. How is an electrical static charge handled with the IC clamp?
Well, the electrical static charge with the IC clamp would have to have a staple put in the end in order to be completely conductive. So for the electrical continuity, you must insert the staple in the end, and and again, this is common practice for anybody who's putting bolt clamps together. Put a staple in the end of whether it's an air hose or a steam hose, and fully electrically ground it. It is not perfect. There is no design for an automatic bite to the wire situation. The staple must be added, and that's how you would ground it.
That's all the questions.
Okay. Hey, well, listen, everybody, thanks for your time, and I hope you got something from it. I'm going to send you a copy of the PDF of this presentation for your use, and a link to the recording, as well as a copy of the Campbell Coupling Selection Guide, which has the derating chart on it. You guys, everybody have a great day, and thanks for joining us, and join us for other webinars. Thank you.